In this video, we're going to take a look at integrating nHibernate in with our web project. So the first step is, well, we actually kind of need nHibernate. How do we get nHibernate? We get it through NuGet. So I'm going to right-click References, say Manage NuGet Packages, like I've been doing. I'm going to search online for nHibernate. Then I'm going to find nHibernate. I'm going to click Install, and we now have nHibernate installed.
That's sweet.
Yep. But nHibernate's not doing anything. We have quite a few steps that we need to actually perform in order to get nHibernate properly configured. What I'm going to do is I'm going to place the vast majority of our nHibernate specific code into a class called database that I'm going to place at the root of our project. So the class database is going to be static, and it's going to have three very important static methods. It's going to have a public static void configure method. It's going to have a public static void open session method. It's going to have a public static void close session method. Okay, the configure method will be invoked at application startup, and it's going to be used to, not surprisingly, configure nHibernate. The open session method is going to be invoked at the beginning of every request, and it's going to open a session. And the close session method is going to be invoked at the end of every session, or every request, sorry, and it'll be responsible for closing our session. So how do we actually have that happen? How do we make it so these three methods are invoked during our application lifetime? The answer to that is in our global ASICs. Our global ASICs is going to be responsible for hooking into ASP.NET, and we can write different event handlers inside of it that will be invoked at specific times. The first one's already been written, application start. All we need to do is go to the bottom of application start and simply say database.configure. This will make it so our database configure method is invoked at the beginning of our application. However, we still need two more event handlers. These, again, are magic methods that are actually found by ASP.NET and invoked at specific points in time. They're not overloadable or overridable methods, nor are they interface implementation methods. Instead, they are simply just methods that are named in a particular way that get magically invoked by ASP.NET, which means their name has to be exact or ASP.NET will not pick up on them. The two methods we need are protected void application underscore begin request and protected void application underscore end request. So when do you think these events are fired, Steve?
Those are going to be fired when you fire up your application, are you? Or
Well, for the begin request and the end request. The begin request will be invoked at the beginning of any request, and the end request will be invoked at the end of any request.
yeah.
Fairly good names.
Even I could have guessed that end request would be the next one.
Yep. So what we got to do is we have to tell our database to open up a session at the beginning of every request, and then we're going to tell our database to close a session at the end of every request. So that's awesome. We've now hooked up our database class into our ASP.NET pipeline, but it doesn't do anything yet. So let's go ahead and start writing nHibernate code. The first step, as you saw in our diagram, is we need to create the configuration object. The configuration object will host our mappings and our connection string, and it'll result in a session factory. So let's start with that. The configuration object is aptly named configuration. The configuration class is aptly named configuration. And the configuration class that we want is located underneath the nHibernate.cfg.configuration namespace. So you see by clicking that, I got a using statement up on line 1. So what we need to do is we need to configure the connection string. We need to add our mappings. Then we need to create our session factory. So let's go ahead and do that one by one. How do we configure the connection string? Well, there's actually a lot of methods on the configuration class that allow us to do that. They're mostly underneath configure. Configure has a couple of overloads. It has one that takes no parameters, one that takes an assembly and a resource name, one that takes a file name, and one that takes an XML reader. The one that we care about is the one that takes in no parameters. The reason why we care about this is it will automatically look at our web.config locate a special section that we're going to be writing in the web.config and use it for the connection string parameters. So let's go ahead and do that. I want to fire up web.config, and I want to configure it to know about nHibernate so that the configure method on the configuration object from the configuration class knows the configuration we need to use.
Gotcha.
That's
It'll be all configured.
It will be very configured. It'll be the most configured thing that can be configured.
Excellent. Well, that's how it should be.
Yes, indeed. So what we need to do is we actually need to extend our web.config. Web.configs and app.configs are very powerful configuration tools in .NET. They are incredibly extensible, meaning that I can add user-defined settings into them. Fortunately for us, nHibernate comes with a class that can be used to extend our web.config file. However, that requires us to actually tell web.config about that class. We do that in a very special section called config sections. Now, the config sections element has to appear as the first element underneath the root element. It has to be at the top. If it's not at the top, you will actually receive an error when trying to load your website through the web server. Now, inside of this, I want to add an element. This element is going to describe to the web.config about the existence of nHibernate configuration options.
Okie dokie.
So the parameters I'm going to pass into this element are going to be, or the attributes, I should say, are going to be a name and a type. The name is going to simply be Hibernate-configuration. The type is going to be a special class inside of the nHibernate assembly that describes to web.config how to behave with Hibernate configuration sections. That class is nHibernate.cfg.configuration section handler. However, in addition to telling the web.config about the type that we want, we also have to tell it what assembly to find it from. So I'll simply put a comma in there and type in nHibernate. nHibernate is the name of the assembly that nHibernate comes from, which seems fairly straightforward.
Indeed.
So now that we've told web.config about our configuration section, we actually need to make our configuration section and, well, put our options inside of it. The order of our configuration section doesn't actually matter. I can place the Hibernate configuration anywhere in this file except above the config sections element. For ease of readability, I'm simply going to place it immediately after my connection strings. That way we can keep everything all open on the same page. So what do I need to do? Well, I need to open up a new element called Hibernate-configuration, and I need to give it an XML namespace. That's done through the XML NS attribute. That's so that we can have this web.config XML file properly validate and properly be located by the nHibernate's configure method. The namespace is going to be urn:/nHibernate-configuration-2.2. Now remember, the only reason we're allowed to place Hibernate configuration inside of our web.config is because we told it about that type. So just keep
Which
that
is why it had to be up there.
Yes. Otherwise we would get an error. Okay, so how do we configure nHibernate? Well, there's an element underneath Hibernate configuration called Session Factory, which configures our Session Factory. The Session Factory element takes a variety of properties. All the properties are expressed in this syntax: property, name equals, and then value. There are going to be three properties that we are required to specify in order for nHibernate to work properly. Those are the dialect, the connection.driver class, and the connection.connection string, _string _name. These are the three properties, the minimum required to get nHibernate to work with MySQL. The dialect property specifies to nHibernate how it should generate its SQL. Remember, not all databases share the same SQL dialect. For example, Microsoft SQL Server has a different syntax for SQL than MySQL. They might be very similar, but there are enough differences that you actually have to instruct nHibernate exactly what kind of database you're working with. You'll notice, however, that we're doing this in the web.config, and you might wonder if you can actually change your dialect to whatever you want if you were to deploy this into production. So for example, you can develop on MySQL and deploy to MS SQL. The answer is yes. And Hibernate is database agnostic, and the dialect is the only time in Hibernate's going to ask you what dialect you're working with. So what we need to do is we need to give it a class name. The class name for the MySQL dialect is aptly named nHibernate dot dialect dot MySQL dialect, and SQL is capitalized. The driver class specifies to nHibernate which class it has to instantiate in order to create a connection to the database. So what we're going to do is we're going to give it nHibernate dot driver dot MySQL data driver. And for some reason, the driver name does not have capital SQL. It just has capital S under you know what I mean, lowercase SQL.
I was going to ask about that. That seemed odd. But
I don't know why it's like that, but it is.
Okay.
The final thing is we have to instruct in Hibernate which database we want it to connect to. So for example, where the database is located, which database within that database, which user, and which password. Fortunately, we have all that information already written in our connection strings, and its name is main.db. That means I can simply type in main.db, and I now have told nHibernate to use this connection string to connect to my database.
Making sense.
Awesome. This is all the change we have to make to web.config to make nHibernate work. Again, we need to add the config sections, then we need to add the 3 properties. Because we've written it in this way, the config.configure method will actually know exactly where to pull it out of our web.config without us being any more explicit. So that's really nice.
That's really handy.
The next thing is a little bit more complicated.
Oh dear.
We need our mappings. I'm actually going to start this video off with just creating a mapping and a corresponding entity for one of our tables. That's going to be the user. We're not going to worry about roles until later, just so we can get through a complete example of using nHibernate first, and then move on to adding roles into it. So what do I need in order to add mappings? Well, I need a mapping. What do I need in order to make a mapping? I need an entity. The mapping needs to be aware of the entity that we're mapping against. What's an entity? An entity is just a class that represents a row in our database. So where are we going to put this class, this user class? I want to have a class called user that is managed by nHibernate and is automatically hydrated with the information in the database. Well, I'm going to place that in my models namespace. It's kind of what it's for. So I'm going to create a new class and I'm going to call it user. Now the user class is going to have properties for all of the different, columns in the database row. For example, it's going to have public int ID, public string username, public string email, and public string password hash. Now there's actually a keyword that I left out when writing this out, and that's because I want to make a very, 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 very big point about it. Virtual. Every single class that you want nHibernate to map to must have all of its members be listed as virtual. Period, full stop. There's no exception to this rule. So every single method, every single property needs to be virtual. There's actually a reason why this is, and Hibernate does a lot of stuff behind the scenes for us. One of the things it actually does is it creates what are called proxy classes. Proxy classes are classes that are created at runtime that inherit from our entity class. Because nHibernate supports the ability to only load particular bits of data when they're requested, it has to override our implementation of our properties inside of its proxy class in order to retrieve that data when it's needed. As a result, the rule is every member must be virtual.
Okie dokie. Should every member be virtual then?
Yes, every member should be virtual.
All right.
And this will bite you. It always will. That should be, and trying to ingrain this in everyone's head because you will forget this. And when you do, you usually get an error that tells you exactly what's wrong and exactly what member isn't virtual. But it's really good just to preemptively make every member on your entity classes virtual. Okay, so as I said, I'm not worrying about roles just yet, so I'm not even going to map them at all. I'm just going to have my user. Again, this user is simply the C# version of this table. Every row in this table will get a corresponding user object, and they will all have these fields, or these properties, sorry. We now have to instruct in Hibernate how it is to go about turning this table, which I'll show you guys the schema of this table right here. I'll try to show you guys the schema of this table. Oh, come on. Here we go. How should nHibernate turn this table into our user class? That is a mapping. So let's make one. There are 1.52 million ways of writing mappings in nHibernate, and I'm only going to cover one of them. The one that I'm going to cover is one that actually has been added very recently, and it's a code-based mapping. It's a mapping that I can do inside of C#. It makes it very easy to not make mistakes, and it also gives a big level of discoverability as far as the options that we have when mapping our entities. The old way was using XML files. In addition, there's another project out there in the wild called Fluent in Hibernate. The new mapping system in code is actually a combination of the sort of ideas of Fluent in Hibernate, but kind of more similar to the XML mappings. So it's a very interesting little thing, and it's now a part of core in Hibernate. And because it's part of core in Hibernate and it does everything the XML mappings can do, I prefer to use it.
That makes sense.
There are also auto-mappers. Fluent in Hibernate, in fact, comes with an auto-mapper. An auto-mapper is a mapper that actually infers the way the database schema should be laid out based off of our entity. We're not going to worry about auto-mappers in this series. Instead, we are just going to map everything explicitly. But you'll see in a moment it's not that difficult to do. What I need to do is I need to create a new class. And I'm going to create this class in the same file as my user class. The name of this class is going to be called user_map. The important thing, the thing that makes this a class mapping, is that it's going to inherit from class mapping. The class mapping class comes from the nHibernate mapping bytecode conformist namespace. Not sure what the conformist namespace is, but the rest of it should make pretty good sense.
Okie dokie.
You'll see that the class mapping requires a generic parameter. That generic parameter is the class or the entity that we're mapping. In this case, it'll be user. Now, the only member that we have to fill out of our class mappings is our constructor. So I'm going to create a simple empty constructor. This is where the mapping happens. We can look at all the ways we can map our entities by doing this dot. All of these methods are used to describe to nHibernate how it should map this class to our database table. But don't worry, the methods that we're going to be using should be fairly straightforward. The first one is I need to tell nHibernate which table this entity comes from by using the table method. I'm simply going to say users. The next most important thing I need to do is I need to tell nHibernate what property is the primary key and how that property is generated or not generated by the database. That's through the ID method. Now, the ID method takes in a really interesting parameter. It takes an expression of func of user and tProperty. That might look a little scary, but the syntax we use to pass something into this parameter is simply a lambda, where the parameter to the lambda is of the same type as the entity, and we effectively just point it to the property that constitutes our ID.
Okie dokie.
Then it can optionally take in an additional parameter. This one is an action of iID mapper. This, if we fill out this parameter, it'll give us more options for our ID, which we will need one of them. So I'm simply going to say x goes into x.generator, generators.identity. So generators actually comes from a different namespace, so I'm going to have to import that. So I click on that, and we now get a using in Hibernate mapping by code without the .conformist. So what does this do? Well, the first step of this is it tells the ID method which one of our properties constitutes our primary key, and then it tells in Hibernate that this key is automatically incremented by our database. That's because in Hibernate supports quite a few different methods of generating IDs. We can go assigned, which just means that we assign the ID manually. We can say GUID, which means that nHibernate will create a GUID. We have the high-low algorithm, which means that nHibernate will try to generate a uniquely unique or a fairly unique identifier. And we have our identity, which we are going to use, which means let the database handle the generation of our unique ID, which is usually what you want. The most common things that I use out of these particular options are assigned and identity. Okay, those are the only two really required things to get this mapping working, but it won't do a lot because we haven't told in Hibernate about our username field, our email field, or our password hash field. So let's do that. We do that through the property method. The property method expects an expression which points to the property we want to map. Let's map username first. And then, just like the ID method, we also have an optional second argument that we can pass in some things that will actually override some of the defaults, which we want to do. Why? Because we want to say that this username column is not nullable. This will enforce on nHibernate's end that whenever we try to insert an entity with a null username, it'll throw an error as opposed to actually inserting it into the database. Now you might be asking, where does the name of the field come in? We specified the name of the property, but we didn't actually tell nHibernate about the name of the field. And if I can find MySQL Workbench, we see that the field name is username. The reason why this works is because by default, if you do not override the field name of the property, it'll default to the property name. Because MySQL, or SQL in general, is case insensitive, uppercase username is the same thing as lowercase username, which means we can get away with not explicitly creating the, or not explicitly defining the field name. We'll see a case where that can't be done in a moment here. Next up, I'm going to map my email, and it's going to be not nullable. So we have two properties so far. Our username and our email, they're both not nullable, and they both work because the field name and the property names are the same. Now let's take a look at our password hash. Our password hash isn't nullable, yes, but you'll see that the password hash actually doesn't follow the same naming convention as our property. So we're going to actually have to override in nHibernate the field name for this column. We do that in much the same way we would normally map something. However, we are going to use the column method and simply say password hash. The column method will override the column name for this property. But we run into an issue. I don't only want to specify the column name, but I also want to specify not nullable. If you aren't familiar with the rules about lambdas, you can have single expression lambdas without curly braces, but if I want to add more than one expression to this lambda, I'm going to have to open up curly braces. So I do that simply by saying x goes into open curly, my block, close curly, and so on. That means that this constitutes the entire lambda, and I'm now allowed to add multiple expressions into it. The second expression I want to add into the mapping for my password hash is not nullable, because I want it to not be nullable, and I want to override the name of the column.
Okie dokie.
That wasn't very convincing, Steve.
It wasn't?
No.
Imagine that. No, I mean that makes sense. It's the curly Q thing. Since I don't know any C#, at least now I understand why that has to be there.
Alrighty. Okay, so we've written our mapping, but we haven't told nHibernate about it yet. So let's jump back into our database and do that. In order to use the new mapping system in nHibernate, we have to instantiate an object called a model mapper. So I'm going to say var mapper equals new model mapper. Now the model mapper class comes out of the namespace nHibernate mapping by code. So when I hit enter, you'll see that a new name using statement appeared up here on line 2 for nHibernate mapping by code. What I'm going to do now is I am going to tell the mapper about my mappings. I can do that very easily. I can simply say mapper.addMapping. Whoa, that's not how you spell mapping. And then as a generic argument, I'm going to pass in user map. Now user map isn't a namespace that is not imported. So by importing it, we'll get a using statement for simpleblog.models. Okay, we've instantiated our mapper. We've told our mapper about our mapping, but we haven't told our configuration about our mapper. So let's go ahead and do that. The last step of mapping is simply to say config.addMapping and then pass in mapper.compile mappings for all explicitly added entities. Okay, so we instantiate our mapper, we tell our mapper about our mappings, and then we tell our configuration about the result of compiling those mappings. And we're done.
Sweet.
We have now added our connection string and our mappings into our configuration object. The final step is to create our session factory. However, our session factory is going to have to be used by our open session and our close session methods, which means I'm going to store the session factory as a private static field on this class. That's because this session factory will be shared between all requests into the application. So I'm simply going to say private static iSessionFactory session factory. And IntelliSense tossed in the word configuration, and I'll remove that. Guess what? Session factory is in a different namespace. So
We need to create a use statement.
yep. And we'll have ReSharper do that for us automatically, and look what we get. On line 1, we get using nHibernate. Okay, so we've created our field. Let's go ahead and actually assign our field to something. So on the create session factory step, I'm simply going to say session factory equals config dot build session factory. And that pretty much concludes all application level code required to use nHibernate.
Very nice.
Again, we configured our web.config with our configuration section and our nHibernate configuration, which told nHibernate about what dialect we're using, what driver we're using, and what connection string we're using. We created an entity, which is simply a normal C# class, but with all its members virtual. We created a mapping for our entity, which describes to nHibernate how to map this entity to a table. And then we pretty much put everything together inside of this method, which creates a configuration, configures it, adds the mappings, and then builds a session factory. That's pretty much all of this right here, what we're seeing at app level.
Alrighty.
So now we have to worry about the request level, because we still don't actually have any way to open up a session. And if we don't have a way to open up a session, we don't have a way to open up a transaction, and we don't have a way to get any data, which is bad.
Yeah, so we want to move on to the request level.
Yep. So to do that, we have the open session and the closed session. What I need to do is I need to, on the open session method, open a session and stuff it somewhere that's unique for the current request. That is an incredibly important concept about what I'm about to do. Remember, web servers, or IIS specifically, is multi-threaded, meaning it can handle multiple requests simultaneously. That brings up a problem. How do we uniquely scope an object to only exist on a single particular request and not be accessible from every other request that might be executing simultaneously? The answer to that question is an awesome little bucket that ASP.NET gives us called HTTP context items. What I'm going to do is on our open session, I'm going to do http context dot current dot items something equals session factory dot open session. This line of code has two problems. First of all, we need to import a namespace. So I'll import it. That brings up a using statement for system.web. The second thing is I need to put something in here. But before I do that, I want to talk a little bit about items. Items is a special little place where I can put any arbitrary object and it'll only be accessible by the current request that is executing on the server. Meaning any code that relies on the items dictionary is essentially thread safe in the context of IAS, which makes it a very ideal location to place our session object. However, I need a key. Every item inside the items dictionary needs a unique key so it can uniquely identify it. What I'm going to do is at the top of this class, I'm going to create a private constant string that will represent the key into the items collection that refers to my open session. So I'm simply going to say private const string session key. Now there are a couple practices that I use for creating keys that are used for my items dictionary. One of them is to create a GUID, but unfortunately sometimes that makes things difficult to debug. Another option is to simply type in the fully qualified path to my constant. So I can say simpleblog.database.sessionKey. By doing this, this string is essentially going to be unique to any other key that I create, given that I followed the same practice. So it allows us to make sure that we won't have conflicting keys anywhere else in our system. Now that I have that constant, I can reuse it throughout this class, which I'm going to use it right here in this index operation. I'm going to say session key for the key of the items. Then I'm going to assign the result of opening a session to that. So session factory.open session, not surprisingly, informs the session factory to open a session.
That makes more sense than anything else I've seen.
Remember, the session is scoped to our request. Every request gets a session, and a session represents an individual connection to our database. So now that I've done that, how do I close the session? Well, I'm going to do two steps. The first thing I'm going to do is I'm going to try to retrieve the session out of HTTP context current items session key as iSession. Now, iSession is the type or the interface that Hibernate uses to represent a session. What I'm effectively doing here is I'm saying, okay, try to give me an object at the session key in my items that is of type iSession. What I'm going to do now is I'm going to say if you were able to get that item out, then I want to close the session. So I simply do session.close. Finally, I want to say HTTP context current items.remove session key, which will remove the current session from our items dictionary.
Okie dokie.
Remember, open session is invoked at the beginning of the request as per our global ASICs, and close session is invoked at the end of a request, which means we properly open the connection to the database and we properly close the connection to the database. But we have one more problem.
How does all this relate to the transaction?
The transaction is going to be handled by our controllers themselves through a filter.
Okay. Alrighty.
But
we still have one more problem.
We do have one more problem. The problem is our database does not in any way expose our session to any other bit of code. What we want to do is we want the database to expose our session so our controllers can use it. To do that, I'm going to create a public static iSession property called session, and it's going to have a getter. The getter is going to return cast to iSession HTTP context current items at session key. Now there's a reason why I'm using an as iSession here and a hard cast right here. If you guys recall, the difference between the two forms of casting is the as will not throw an exception if it's incapable of performing that cast, whereas this casting would. So what I mean is that if any of our code tries to reference this session, and for some reason our session hasn't been initialized or isn't the correct type of object or some other thing went wrong, I want it to throw an exception so that I as the developer can figure out what went wrong and who's using this incorrectly. However, with the close session, I want to handle the possibility that a session was never opened in a request, even if closed session is invoked, which can happen sometimes, especially if you're trying to make sure that requests to like images or files or something are not resulting in the opening of a database connection. So there is a reason why I'm using as here and a casting here. I can't tell you how many times I get asked why I use casting and hard casting and why I use the as operator. Either way, we now have access to our session. We now have access to all of the entities inside of nHibernate and our appropriate database connection. Let's not worry about transactions quite yet. I just want to see the session being used somehow. Then we'll worry about transactions. So I'm going to close out all my files because I've essentially configured my nHibernate install. I've configured my global ASICs properly. I've created a database abstraction. Now I can use it to do something. So let's, well, do something. In the next video, we're going to talk about the users controller, but I want to go ahead and just implement a little bit of it for now so that we can see our session in action. Now, our admin is going to follow the same pattern of view models as our front end. Remember how I have this view model namespace that contains our view models? And remember that a view model is the data that is allowed to be passed from a controller to a view?
Yep.
Well, that effectively represents this line, or I must have removed that diagram, but there was a diagram of a view somewhere. We need to tell nHibernate to get data, stuff it into a view model, and then hand it off into a view. Now, there are going to be no models in the admin area, so I'm simply going to rename the models folder view models. Then I'm going to create a file called users. I'm actually creating a class, but I'm going to rename this class to something else. I'm going to rename this class to users index. Remember, the view model format that I use is controller followed by action. Now, what data type does our users index need to be? Well, it needs to be whatever data type that nHibernate is going to return back for our entity, which happens to be a IEnumerable of, whoops, wrong one, IEnumerable of user. And I'm going to call it users. Why do we need an IEnumerable of users? Well, an IEnumerable of users represents a collection of users that I can present on our admin form. I want to list all the users. You might want to take note that two using statements did pop up: system collections generic and simpleblog.models. IEnumerable comes from system collections generic, and obviously user comes from simpleblog models.
Gotcha.
Now that I've done that on my view model, I've created my view model. Let's go ahead and use it. I'm going to go back into my users controller, and I'm going to instantiate my user view model and pass it into the view. How do I do that? I simply say new users index. Now, that brings in a using simpleblog areas admin view models because the users index class is inside that namespace and so on and so forth. Now, the users index view model has a single property called users, and I need to assign it to something. What do I assign it to? Well, I can simply say database dot session dot query of user dot to list. Now, you might notice that a bunch of using statements just appeared. We didn't need a using statement for database because it's in a child namespace, but we did need a using statement for query. Specifically, we needed using nHibernate.Link. See, nHibernate gives us a bunch of different ways to query over our objects. We have HQL, Direct SQL, Criteria API, Query Over API, and Link. We're going to be using Link exclusively in this video series, but just be aware that there are other ways to use nHibernate. So the query method comes from the nHibernate.Link namespace. Next, we needed user, because we want to say what entity we're querying on, and the user class is in the simpleblog models namespace. So that's why that popped up. Finally, we needed toList. We needed toList because we want to actually turn this query into a collection of objects in memory. We want nHibernate to go out and retrieve all the rows of our user and bring them back to us. The toList method comes from system.link. Okay, so what does this code do? This code retrieves every single user in our database and returns them as user objects. That is literally all the code we need to do database access now. Because of all the configuration that we've done through the last 40 minutes, we can now do something as simple as this to retrieve a list of users. Sound good?
That sounds awesome.
So now let's go ahead and actually use our view model in our view to present a list of users to the user. I'm going to open up views, users, index.cshtml. I need to strongly type this view to be of the same type as the view model I'm passing in on users controller. So I'm simply going to type in model, simple blog, areas, admin, view models, users index. And then I'm simply going to say, the markup I'm typing doesn't matter. We're going to replace it very shortly here. But I'm going to say for each var user and users, user.username. If we are able to compile this project, which I just did, F6, and if we are able to load up and this view, we should be able to see Steve. If we do, that means we have nHibernate configured properly.
Excellent.
So let's see if we do, because I have a feeling we probably don't.
That's not excellent.
Oh, my web server stopped for some reason. See, I got an error on Chrome, and I looked down to my status bar, and there's no IIS Express. How do I restart the web server? Do you remember?
No.
Control F5.
Oh, yeah, that's right. Oh, I should have known that. F5, Control F5, and F6.
Okay, I got kicked back to the login screen with this really horrible yellow that's seriously burning my retina. Look at that. You see that?
I see that.
Let's insert another user and see what happens. And how about another one? Hit apply, hit finish, come back to the page, hit refresh. We have data being pulled out of the database and onto a website. Sound good?
Yeah, I thought you'd about words and things. I thought you thought this would break.
I did think this would break. About half the time I do this from memory, it breaks.
All right, so we're on the good side of the 50%. I like that.
Yeah. Again, it's a process that involves so many moving parts that it could be very frustrating to users. And so if this was confusing, I would highly recommend going through these steps one by one. And I tried to make each step at least explain why we have to do each step, because it does make sense even if it sounds like a lot of work. You might be saying, well, some frameworks just give me an ORM out of the box. That's true, but nHibernate is a very powerful ORM, and ASP.NET doesn't force you to use any specific ORM, which is great, and it's terrible at the same time.
And if you are having problems, you should really look for misspellings and whether or not you hit F6 and rebuild.
Yep.
All right.
Okay, so I think this wraps up this video. We're going to go ahead and deal with the many-to-many association between users and roles in the next video. If any of this was confusing, I recommend rewatching this video before moving on.
Before we move on, do we need to commit?
We do need to commit.
Yay!
All right, I'm going to open up source tree. I'm going to stage all of my changes. And then I'm going to commit. And I'm going to say added and Hibernate. Added and configured and Hibernate.
Nice.
All right, we'll see you guys in the next video.